Okay, welcome to this tutorial. In today's lesson we're gonna see how to find one-sided limits and how to determine the continuity of a function, and so we're gonna see some examples, and we will do some exercise after lecturing. It's expected at the end of the class one can determine the continuity of a piecewise functions, something like f of x equal to this piecewise function. This is not available. So first let's understand what is one-sided limit. When you say that one-sided limit, it means finding a limit from right side or from negative side. It means from positive side as we approach from positive side, or as we approach from negative side. If we approach a from this positive side, we say that right hand limit of f, and we denote it by limit of f of x as x approaches to from positive. It means from this side. And if it is from negative side, so it is from left. So from left, when we approach this one, we we call it left hand limit of f at x equal to, for example here, b. If it is a, so there's a. So this is what is one-sided limits. To find a limit at a, finding a limit at a means finding the limit from both negative side and from positive side. From both a negative and positive side, it must approach to the same number. So for a limit to exist, that means the limit of f of x as x approaches to a is exist, and we say that it have a limit of L if and only if the limit of f of x from both right hand and left hand side are existed and they are equal to the same number L. Let's see some examples. For example, if we want to determine the limit of radical x plus 5 as x approaches to minus 5. So when we see this radical of negative number does not exist, so at minus 5 it means minus 5 plus 5 is 0, so radical 0 is 0. It is defined at minus 5. But from positive side, for example, if you approach from positive side, like for example 5.0001, 5.01, like this, if you approach that, it means, for example, minus 4.9995. it is radical of 0.00005. it is positive number. Since radical of positive number is existed, when we approach negative 5 from positive side, we get the limit of these functions to 0. But if we find the limit from negative side, it means, for example, minus 5.1, minus 5.001. For example, if we substitute minus 5.0001, it gives minus 0.00001. Radical of minus negative number does not exist. So we say that this limit doesn't exist, since both the limits does not exist and are not equal. So from positive side, like for example when 0 anyways, and from negative side doesn't exist, so the limit of this function as x approaches to negative 5, it doesn't exist. This is one-sided limit. Now, after knowing this one, let's continue. What is continuity? So when we say continuous function, we say that if the graph of a function is a single curved curve in a plane that can in principle can be drawn without lifting the pane of the page, then we call it continuity. Mathematically, we can define this statement as if both the limit of but here it is for a point. If we say that the function is continuous at a number or at a point a, then the limit of this function must be equal to f at that number. That means a must be the domain of f of x plus the limit must be existed and equal to the defined number. So to be continuous at a, it means first this f of a must be defined. So for example, if there is a denominator, for example x, so at x equal to 0 it is undefined for that function, so f is not continuous at f equal to 0. So to be continuous at a, f of x must be defined, that's the first, and also the limit must exist. This means if this f of x as the limit as x approaches to a is existed if and only if both left and right hand side of the limit exists and they are equal. So if this f of a is defined and the limits are existed, the third is they should have the same value. It means this limit, the existed limit, and the defined functions at that point must have the same value, unless it is discontinuous at a. Let's do some examples. Okay, the question is, are they continuous over real number, all real number? So for example, this is irrational functions. If it is rational functions, the only thing we should check is its denominator, the number that makes the denominator, because we can substitute any value of x except this denominator that makes this denominator equal to 0. So to be continuous over all real number, we have to check this one. If we substitute 2, so it will be 0. So at 2 it is not defined. That means this function is not continuous at 2. Simply f of x is not continuous over real number. Let's make it let's define at a point x equal to 2, let's define 4, and this functions is as x differ from 4, x differ from 2, it is a function x square, this the same functions, and if x is 2, then g of x is 4. This is, we make it piecewise function. For most of function, for we call this kinds of function as this discontinuity can be removable, so removable functions. So let's check it if it is defined or not for g of x. So for the first one, since at x equal to 2 is not defined, therefore it is not continuous. For the second one, first we have to check if it is defined. So g of a is defined, since for all real number, for example for 2 it is defined 4, and for x differ from 2, so we can substitute and we can get any value. So its domain is all real number, so this is defined. This is the first one, and we have to check the limit. Since g of x is x square minus 4 over x minus 2 for x differ from 2, so this x square minus 4 can be factorize x minus 2 times x plus 2. Since x minus 2 can be cancelled out by x minus 2, then the limit can be existed. So this limit is exist, and the third we have to check is if this limit and g of a are equal. We know that g of 2 is 4, because for x equal to 2 it is 4, so g of 2 is 4, and we're gonna find the limit. The limit of g of x is the same as, since x square minus 4 is x minus 2 times x plus 2. X minus 2 will be cancelled out by x minus 2. It will be the same as x plus 2. So the limit of g of x is the same as finding the limit of x plus 2 as x approaches to 2. Then substituting this value, it gives 2 plus 2, which is 4, and the limit of these functions 4 is the same as that of the defined at g of 2. So we conclude that this g of x is continuous over all real number. Okay, let's see a third example. Find a and b so that the function is continuous. If this function is to be continuous, then the limit at each value must be defined, and also the limit also existed and equal to their defined function as we discussed before. So for x less than 2, f of x is defined by this function a plus 1 times x square, this function, and for if x is equal to 2 it will be b. So, and if it is greater than 2, we have these functions. So let's see their limits, and the only point we must check is x equal to 2, because here it is rational functions. For rational functions we will see this denominators to check they are continuous or not. So when we substitute it, if we substitute at 2 it gives 0, but for these functions for x less than 2, so we have to find from left side and from right side for greater than 2, and we gonna if they are equal we have to check if they are equal to these functions. So to be continuous, the first thing is if it is continuous, so this limit at x approaches to a for all functions must be defined this one. So let's gonna find first from negative side. Since it is piecewise at 2, let's check if it is continuous or not at a point x equal to 2. So the limit of f of x as x approaches to from negative side is a function defined by these functions. Since for x less than 2 from negative side, it means we have these functions. So for negative side we have these functions, then this x square minus 4 is, as we done before, it is x plus 2 times x minus 2, so it gives a plus 1 times x minus 2 will be cancelled out by x minus 2, and it gives x plus 2. So the limit will be the same as the substituting 2 here, it gives 4 times a plus 1, so 4a plus 4. And from positive side we have a function defined by this one. Since x greater than 2, that means for positive number, for example 2.0001, if we need to substitute this value we use these functions. So for positive side we use these functions. So finding the limit of these functions is the same as substituting here 2. So when we substitute 2 from positive side it will be positive number, then 0.0001. as we did before, it is radical, so it will be 0. 1 plus 0 is 1, so 1 times 2a plus b is the same as 2a plus 2b. This is 2b, sorry. And then to be continuous, so the limit should exist. So the limit existed if only if there's two, that means the left hand and the right hand side limits must be existed and they must be equal. That means 4a plus 4 must be equal to a plus 2b, this one. And the second thing is, after this limit exists, this limit value must be equal to that of f at that point. So f at 2 is defined by a function f at 2 is b, so this b must be equal to the limit of this one, that means 4a plus 4 or 2a plus 2b. So we will use those two equations for a plus 4 equal to 2a plus 2b and 4a plus 4 equal to b, and we find using simultaneous equation, and we get finally minus 2 over 3 and 4 over 3. If a is minus 2 over 3 and b is 4 over 3, this functions is continuous all over real number. As exercise, try this one, and if you have difficulty, please write on comment and we can chat. Okay, it's enough for today. Goodbye.